In this video, we are going to learn the quotient rule of derivative. So if there is a function p of x, f of x has been divided by g of x, so it's a quotient. P prime of x, the notation is very clumsy. F prime x gx minus fx times g prime of x divided by the value of g of x squared it. Or if we just simplified the a over b, still is too much work. Derivative of a over b is derivative of a times it by the b minus a times it by the derivative of b, everything divided by b to the power of 2. Much the easiest one. P of x is a over b. Come to the realistic one. P prime of x is a prime b minus ab prime divided by just the value of b squared. We will follow the last notation. So what if we have 4x divided by x plus 1? We have to find the derivative. So f prime of x. Let's not do the derivative, just the plan. Derivative of the a, which is derivative of the top, prime it. We haven't done derivative, just following the formula. Multiplied by the value on the bottom, so multiplied by x plus 1. This is minus of the top value, minus of a. B prime is x plus 1, prime it. We have to find the derivative of that. Everything divided by x plus 1 whole power of 2. Now proceed with derivatives. So derivative of 4x is just 4. The blue value, just copy the x plus 1. Minus, copy the 4x. Find the derivative of x plus 1. Derivative of x, which is 1x, is just 1. Derivative of the next constant is 0. Everything divided by x plus 1 whole to the power of 2. Final simplification. Copy the denominator. Let's see if we can cancel it later. First, simplify the top. 4 times x is 4x. 4 times the 1 is 4. And it's negative 4x times 1. It remains to be just negative 4x. The positive 4x, the negative 4x is gone, cancelled. So it's going to be 4 divided by x plus 1 whole to the power of 2. And we are done. So a prime b minus ab prime divided by b squared is the fastest notation we can use to speed up our math. Another simple example of quotient law. After that, we were going to do a harder example. Y equals x squared minus x plus 1 divided by x squared plus 3. So we follow the a over b law. A prime b minus ab prime divided by b squared. So y prime, derivative of the y value. First on the top, plan is derivative of the a, derivative of the terms on the top. Multiply that by the derivative of the bottom value, which is by b, so a prime b, minus, copy the a value, which is x squared minus x plus 1, times it by b prime, so x squared plus 3, we have to prime it. Everything divided by the blue value, the b value squared. That's our plan. Now we proceed with derivative. So derivative of the first one, derivative of x squared is 2 times x, power of 2 minus 1 is 2x. Negative of x, derivative of that is just negative 1, it's negative 1x. Derivative of 1 is 0. Copy the blue value. Minus, copy that value, then we will find the derivative of the b value. So it's a, b prime is, derivative of that is going to be just 2 times x to the power of 2 minus 1, just 2x. 3 is a 0. So that's the derivative. Everything is divided by, we just keep the value as is. Sometimes it gets cancelled, sometimes we will leave it like this. All derivative is done. Now is the time of simplification. It's going to be 2 times these two other values. So all we are doing is distribution. 2 times x squared is 2x cubed. 2x times the 3 is 6x. Negative of x squared and negative of, so it's going to be negative x squared and the negative 3. This value, we are going to simplify it in a faster. Every value, whatever is the value comes, we will multiply it by negative. So 2x squared is 2x negative, 2x cubed negative, 2x squared positive, negative x times that's x squared, and it's going to be 2x negative. So it's negative 2x cubed with a 2x squared positive, that was negative, 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 positive. It's a very simple distribution. 2x times 1, positive, this negative will make it negative. The denominator, we just keep it as is. The numerator is so much values. Let's just proceed with the same like term. These two terms are same, and positive and negative, they get cancelled. Then we have a 6x. Sorry, let's proceed for the bigger value. We have a x square, we have a 2x square, and we have a x term, we have x term, and the number term is all alone. So it's going to be x square value first, negative of 1x square, positive is going to be just a positive x square on the top. We are copying the denominator, so it's just x square. The 6x positive, the 2x negative is going to be a positive 4x. The typing, there is a mistake, and that is a negative 3. So I just make a correction. Sorry about that. It is definitely a positive 4x. 6x positive, yes, that was positive. And 2x negative is positive 4x. And that is our final answer. We can factor, we can try to factor out, but we can see if I factor the top, we are not going to get a x squared plus 3 on the top. That's confirmed. So we just leave it like this. That is our final answer. In this example, we are going to handle a radical with the quotient law. First of all, we have to come to a term. We will use a definition now. It was done in the previous videos in the introduction one. If you haven't seen it, f of x is root of x, which is x to the power of 2. So the power of n is half. F prime of x is going to be the exponent times x with the half with a negative 1. So it's going to be half times half minus 1. We just play by the fraction law. Is the 1 we converted 2 over 2. I'm going a little bit fast because it was done before. And later you can pause the video and see the steps. Finally is half times x to the power of green half, and that value is negative half. Finally is going to be 1 over half times 1 over x to the power of positive half. And finally the x to the power of positive half, that will be simplified as square root of x. So that comes as a definition. Whenever we have this, derivative is this. So we just make a note. We can convert it, we can simplify it further, but we just take a note. It will be used off and on calculus. F of x is root of x. F prime of x is half times 1 over the whole value. When the chain comes, we don't need any chains over here. Now, derivative of this value, f of x is 2x plus 8 over root of x. F prime of x, just follow the law. A prime b minus ab prime divided by b squared. So a prime is top value, prime it, we have to find the derivative, times it by the b value, which is root of x, minus the a value, which is 2x plus 8, times it by b prime. So root of x has to be primed. That means derivative has to be done. All divided by root of x, everything powered by 2, which is b squared. Now let's proceed with the derivative. Derivative of this yellow value. Now, when things are getting so complex, whenever we see a constant, we won't talk about it because derivative of constant is 0. So derivative of 2x is just 2 times it by root x, simplifying. Negative, copy the yellow value as is, 2x plus 8. Derivative of that root x, we just use the definition, is going to be half times 1 over root x. So that part, we use another parenthesis, is half times 1 over root x. Done. All divided by the blue value. The blue value will get simplified. The power of 2 and the root, they get cancelled. It's just the x. Now we have to simplify the top. Now one thing is, when we factor out a 2 from here, because if we take one more step, we have to write the whole long math. The 2x plus 8, if we factor out the 2, is going to be 2 times x plus 4, and with the negative side outside. So this 2 value, we just write it in the factor format, sorry, in the fraction format, because we are going to have a fraction on the right side term on the top. So 2 times root x over 1, we just use the fraction mode, minus, if I factor out this 2 from here, it's going to be negative of x plus 4 times the 1 times the 1, and this is 2 times root x. That was the reason we factored out in the beginning, otherwise we had to write it one more time to show the process. 2 on the top, 2 on the bottom, they get cancelled. Now one more thing is we have to, okay, everything is divided by the x. Now we have to defraction it. This has to get cancelled. So with respect to root of x, we multiply the top and bottom by root of x. This is done to cancel this x. Now the next term is going to be x. This x times root x is x times root x on the top. The green root x times the root x is x times the 2 is going to be just 2x. Minus this on the second term comes. That value and that value is going to get cancelled. So the second term is going to be negative of x. Negative times the positive 4 is negative 4. Simplified. And we have a 2x minus x. So finally it's going to be x minus 4 divided by x times root of x. And we are done. That's the final answer. We have another example of a quotient, a value divided by a value. So f of x is 2x cubed minus 1 divided by that. If we jump and use the formula, we can do that. It's going to be lots of work. So we have to watch and learn. Sometimes rearranging is a better option. How can we rearrange? We have a common denominator, right? So we can use the algebra, x squared with the denominator, and we can just separate the two numerator. We're just using the fraction law. It's the common denominator, 2x cubed minus 1, we just separate it. So 2x cubed minus x squared minus 1 over x squared. If we simplify, we go back to the top value. What is the reason behind it? Simplification is a better option. If we just cancel this 2, it's going to be 2x there. And we are just having this one. We can just rewrite it as a x to the power of 2. So this simplifies as a simple 2x. And that is x to the power of negative 2 using the exponent law. It has become tiny and miny. And we can go back to the introductory derivatives. Find the derivative of the first term, find the derivative of the next term, and we are done. So f prime of x, derivative of 2x is just 2. Derivative, subtract, derivative of x to the power of 2 is negative 2 with the x with another power of negative 2 and a negative 1. Done. Simplification is going to be 2, the first value, negative times negative is going to be positive of 2. And that will be a x to the power of negative 1, negative 2, negative 3. All we have to do is 2 plus, change the negative exponents. So 2 on the top, x negative 3 goes down with x positive 3. Just rearranging made it extreme faster. We have another tricky example. I wish I could show you using the a prime b minus ab prime over b square. I will get very old. I'm already an old man. It's a very long 3 term divided by 2 term. You can see the value is x squared plus 5x plus 4 divided by x plus 4. Using the AB prime notation, yes, we can do it. Extreme loss of work. If we can just see these values and go back to our previous mathematical life, we can easily factor that term. We have a 5x, we have a 4. 4 times 1 is 4. 4 plus 1 is 5 with the x. So all we are doing is just factor the top. Sometimes simplification is the best method rather than jumping to formulas. Doing that, the x plus 4, they get cancelled. Finally, all we have to do is find the derivative of x plus 1. Y prime, find derivative of x, which is 1. Derivative 1 is 0. It was about 5-6 minutes long math, maybe done in less than a minute, and we are done, finished.